Hello guys, welcome to Learn Ingenuity. Today we'll see some MCQs on differential calculus. So let's start. As we know, calculus is a very vast topic and very big also. So we cannot solve all types of MCQs as we have limited time, but we will cover all the topics and we will solve some basic MCQs on those topics. So we will start from the differential calculus. In differential calculus, we will cover these topics. First, we will see limit and continuity. So the first question, limit x tends to 0 sin 1 by x equal to dash. These are the options. Before solving the question, let's see what is limit of a function. Let's understand what do we understand about the limit of a function. So this is the definition. The definition is saying a number a is said to be the limit of a function f of x at x equal to a if for any arbitrary chosen positive integer epsilon, or you can say this is e, epsilon or e, you can say anything. For positive integer epsilon, very small positive, there exists a number delta which is also positive such that f of x minus a mod value is less than epsilon for all value of x for which 0 less than mod of x minus a less than delta. If you read this definition 2-3 times, you will understand that first it is saying f of x at x equal to a. When this will be true, this is the condition. X minus a mod is less than delta for which there exists f of x minus capital A mod is less than epsilon. What is delta and epsilon? These are small positive values. So this is the definition of limit of function. Let's move on to the next. For limit of a function to exist, left hand limit LHL, right hand limit RHL should exist and left hand limit equal to RHL. This is the basic requirement for a limit to exist. Left hand limit should be equal to right hand limit. And the next point is limit of a function can be any real number, either 0 or infinity or minus infinity. Between in minus infinity to infinity, it can be any real value. For example, limit x tends to 0 1 by x square. The answer is infinity. And limit x tends to 1 x cube minus 1, the answer is 0. If you put 1 here, 1 cube minus 1 equal to 1 minus 1 equal to 0. So the answer is 0. So coming to the solution of the question that I have given in the first place, as x tends to 0, what is 1 by x? As x equal to 0, and 1 by x will goes to infinity. Infinity means it will increase pi by 2, pi, 3 pi by 2, like 300 pi, 10 to the 6 pi, 10 to the 100 pi, it will go like this, it will never end. 1 by x tends to infinity, so it will never stop or end. As we know, sign values are always between 1 and minus 1. So this is the graph I have drawn for sin x, f of x equal to sin x. This is the graph. As you can see, the values are in between plus 1 and minus 1. The graph is in between plus 1 and minus 1, and x, for x is infinity, the value will oscillate between minus 1 and 1. So we can say there is no definite number towards which sine 1 by x approaches. It can be any number between -1 to 1, as infinity itself is not a definite number. So sine value will be between minus and 1. So it will endlessly oscillate between the values -1 and 1. So you can say limit extends to 0, sine 1 by x does not exist. So answer will be does not exist. Answer will be D option. Coming to the next question, it is saying limit extends to 0, tan x by x equal to dash. These are the options. So before solving that, let's see some standard results. These results are obtained by proving or by doing some experiments. So we cannot prove all these results. Better we remember these to save our time. These results we will use in our questions. So limit extends to 0, sine x by x equal to 1. Limit extends to 0, cos x equal to 1. Limit extends to 0, tan x by x equal to 1. Limit extends to 0, 1 plus x to the power 1 by x equal to e. What is e? E is the Euler number whose value is 2.718. Like pi, e is also a number. Irrational number, you can say irrational number is Euler number whose value is 2.718. It will continue like this. So here limit extends to 0, 1 plus x to the power 1 by x equal to e. This is the standard result. So similarly limit extends to infinity, 1 plus 1 by x to the power x equal to e. Similarly limit extends to a, h to the power n minus a to the power n divided by x minus a equal to n a to the power n minus 1. So these are some standard results. So as I have asked, limit extends to 0, tan x by x equal to dash. So the answer will be 1. So this is a graph between between y and x, where y equal to f of x equal to sine x by x. So this is the graph. As we know, the standard result says limit extends to 0, sine x by x equal to 1. This is the standard result as we saw earlier. This is the standard result. So if you plot the graph sine x by x, this is the graph we will get. You can see here it is 0, so at 0 the value is 1. So obviously the limit will be also 1. So limit extends to 0, sine x by x equal to 1. I have shown here the graph because you get more clarity how the function are how the limit of the function are varying. If you take here limit extends to pi, here it is pi, so limit extends to pi, sine x by x equal to 0. From graph also you can say where is the limit value. So let's see what is the graph of tan x by x. We saw earlier that what is the standard result, limit extends to 0, tan x by x equal to also 1. So here I have drawn the graph of tan x by x, f of x equal to tan x by x. You can see at 0 value, the value of graph, here you can see this is the graph. This is the function tan x by x. So at 0, it is showing the value is 1. From graph also you can find the limit, but it is not possible to draw the graph in the exam, so we apply the standard formulas. But for the clarity purpose I am showing you What is the graph? This is the graph of tan x by x. So if you put x equal to 0, or you see the value x equal to 0, this is showing the value 1. So from the standard result also it is saying limit x tends to 0, tan x by x equal to 1. So the answer will be A option. Coming to the next question, limit x tends to infinity, x plus sin x divided by x equals to dash. These are the options 2, 0, 1, infinity. X plus sin x divided by x. This is the function given and it is asking what is the limit value as x tends to infinity. So what we will do, we will divide both the numerator and denominator by x. So divide x in both numerator and denominator, what you will get? This x will be 1 and sin x by x, and here x by x equal to 1. This you will get. Then you can apply limit to the sin x by x value. This is also a standard result. Limit x tends to infinity, sin x by x equal to 0. So if you apply this standard result here, the value will be 0 here, so the final answer will be 1. So this is the standard result, we used it here. This is also very important result. Limit x tends to infinity, sin x by x equal to 0. So these are some more standard results. Limit x tends to infinity, sin x by x equal to 0. Limit x tends to 0, e to the power x minus 1 divided by x equal to 1. And limit x tends to 0, a to the power x minus 1 divided by x equal to ln a. So the answer will be here 1. Coming to the next question, the question says limit x tends to 0, sin 1 by x whole divided by 1 by x equal to dash. These are the options 1, 0, infinity does not exist. So let's see. Sin 1 by x divided by 1 by x. Divided by 1 by x, we can take it to the numerator and it will become limit x tends to 0, x into sin 1 by x. If you take x to numerator, it will be like this. And we know limit x tends to 0, x equal to 0. And if you put 0 here, sin infinity. And we saw earlier sin infinity, it can take any value between 1 and minus 1. It can take any value between 1 and minus 1 means it can be 1, it can be 0.5, it can be 0, it can be minus 0.5, it can be anything between minus 1 and 1. So you cannot predict which value. Even if it will be any value between 1 and minus 1, if you multiply that value with 0, what will the answer? 0. So the final answer will be 0. This is a very good question. So the answer will be 0. Answer is B option. So let's see the next question. Limit x tends to 0, sin square x divided by x is equal to dash. These are the options 0, infinity, 1, minus 1. For your clarity, I want to just say sin of x whole square. We can write it as sin square x. These are the same things, but sin of x square, sin of x square is different. These are the same, but this is different. So you should keep in mind these are the same and this is different. So it is saying limit x tends to 0, sin square x divided by x is equal to dash. So let's see. So sin square x by x, we can write it as sin x whole square, sin x whole square divided by x square into x. We can write it like this. So you can apply the standard result here. Limit x tends to 0, sin x by x equal to 1. Here you can apply the standard result, sin x by x, limit x tends to 0, sin x by x equal to 1. So it will be 1 square means 1 into 0 equal to 0. So the final answer will be 0. So the answer is A option. So coming to the next question, it is saying limit x tends to 1, x to the power 5 minus 1 divided by x minus 1 is equal to dash. So these are the options 0, 1, 5, infinity. So let's see how to solve this. So it is saying limit x tends to 1, x to the power 5 minus 1. How can write 1? 1 to the power 5. 1 to the power 5 is also 1. So divided by x minus 1. So we have seen the standard result. From the standard results, limit x tends to a, x to the power n minus a to the power n divided by x minus a is nothing but n into a to the power n minus 1. So what is n here? Here n is 5 and a is 1. So if we put this formula here, we will get 5 into 1 to the power 4 and finally you will get 5. So 5 is the answer. So here C option is the correct option. So what concept did we discuss today? We saw what is limit of a function. We saw what is the definition of a function, definition of the limit of a function. Then we saw for the limit to exist, left hand limit should be equal to right hand limit, and limit of a function should can be any real value between minus infinity to infinity. Then we saw some standard results. We saw many standard results. Then we solved some MCQs applying those standard results. So this is all for today. Hope you guys enjoyed it. See you in next video.